Right, just a little skill work here. Finding the quadratic equation that produces these roots. There's a textbook method. I tend to do it a little differently. So we're trying to get to ax squared plus bx plus c equals 0. Right, solving that. And normally we maybe put this in graphing form. Plus k equals 0, right? And then we solve for x. Well, nothing says we can't go backwards in that process. So we want to get 0 on the right side. Why don't we move the 3 first? I'll do an extra step here the first time because this comes from what? This comes from, let's see, we're going to square this side. We'll square this side. Do I want to show that yet? Yeah, let's just do that. So if I square this side, I get 16i squared. We've gotten better at squaring binomials. X squared minus 6x plus 9 equals minus 16. And so the final answer was x squared minus 6x plus 25 equals 0. Textbook method would probably look at this from the standpoint of factoring. So x minus 3 plus 4i times x minus 3 minus 4i. Difference of two squares, really. We can see the squaring process there. And then I find that, and I got to set it to 0. So you're going to get x squared minus 6x plus 9 from that squaring process. And this is kind of like a conjugate, right? No middle terms. So we've got minus 4i times positive 4i, which is minus 16i squared. And we're getting to the same place, right? I prefer this because you can actually cut out everything in the middle and just write the equation. I suppose you could do the same thing here with a little practice. All right, just doing some skill work. So I'm just going to use the way that I like to do it. So I'm going to bring x plus 6 to this side. I've got the plus minus square root of 3 on this side. I'm going to square both sides, x squared plus double the product. 12x plus 36 equals, when you square this, you just get 3. And now we got to subtract, in this case, x squared plus 12x minus 33, plus 33, excuse me, equals 0. And we've been completing the square on those, solving, getting here. So it's go in the reverse order. All right, so let's do another one. So x minus 9 will equal plus minus 2i. Squaring both sides, x squared minus, what do we get? 18x plus 81 is equal to squaring this 4i squared. Final answer, x squared minus 18x, subtract 4 from 81. Well, it will be negative 4, add 4. 85 equals 0. 2 more, 3 more. So I'll bring the 5 to this side. Square root of 7i. All right, square root of 7i. And we're going to square this. X squared plus 10x plus 25. Moved it a little further to the left, trying to line up those equal signs. 7i squared, which is equal to minus 7. So we're going to add 7 to this side. X squared plus 10x, that's 732 equals 0. Hope you're getting the hang of this. Next one, minus 8, x plus 8 equals 3 root 2. Square both sides. X squared plus 16x plus 64 is equal to, got to square this, so that's a 9. Got to square that, that's a 2. So that's 18. So x squared plus 16x, take 18 away, so that's 46 equals 0. And the last one is a little bit different than the others. So what we really have is we have 2 factors. One is equal to 3/4, the other is equal to 2/5. So let's move this 3/4 up here. And if we, same technique, we want to get a 0, we multiply by 4, set it to 3. 4x minus 3 equals 0. Same thing with this, 5x minus 2 equals 0. How do I make it quadratic? Well, these are factors. So 4x minus 3 times 5x minus 2 equals 0. This is what gets you answers of 3/4, and 2/5. And I'm gonna erase, get an eraser here, get rid of some of the stuff there that gets in the way of seeing. So if x equals 5/2, 2/5, sorry, if x equals 2/5 is an answer to a quadratic, that means it's a factor. And if x equals 3/4 is the answer to a quadratic, it's also a factor. It's factors together, and you got yourself 20x squared minus 8 minus 15 minus 23x plus 6 equals 0, and you're done. All right, that should be enough practice to get us well on our way to doing those by May 15th, quickly and easily, especially if we do one every day. All right.